In a previous episode I demonstrated this model stamper battery that I built. One key factor in this build was connecting the cams to the camshaft with keys in a keyway and actually machining those keyways. So you can see here the cams have keyway slots in them and the shaft has a slot in it, and between the two is a key, and the key was made as a notched key as shown in this diagram. The area in pink represents the cam. The hub of the cam is actually circular, of course, and it has a notch in it which locks into a similar notch in the key. So the key is shown in blue and it has a rectangular notch in it which locks into the notch that's in the cam. And meanwhile the key itself slides along a keyway in the shaft, which of course is also round. So we've got three components here. Let's go over that again. It's the shaft, which has a keyway in it. Sitting in that keyway is a notched key, and sitting in the notch of the key is the cam with its notch. And it's designed this way because the notched key cannot slide along the shaft because it is fitted alongside other keys which prevent it from sliding along. And since it can't move, the cam itself can't slide along the shaft either, and neither can the cam rotate on the shaft. The primary purpose of the key is to prevent the cam from rotating on the shaft. So it does two jobs there. It prevents it sliding along and prevents it from rotating. So it looks complicated, but it's rather a neat way of locking it all together, and also the way it's locked prevents the key from coming out as well. In fact, you might be wondering how we got the key there in the first place. Well, it's quite simple really. You put the key inside the cam first and then slide the whole assembly onto the end of the shaft along the keyway. Here we go. This is what it looks like in assembled form. You can see each of the keys are separate for each cam. The positioning of the cam is quite important. It has to avoid hitting the stem, but does have to hit the bottom side of the tappet to lift it, and to lift the stem and hammer. You may recall that each of the cams has the key slot in a different position, so that they are positioned separately in different places on the shaft, because you don't want them all operating simultaneously, of course. In fact, there's a particular firing order they have to use, and typically it goes 1, 5, 2, 4, 3. You may also notice that there are little punch marks on the cams to indicate what position they take on the shaft, and they are numbered 1, 2, 3, 4, 5 in that order, but they actually drop in the order I just mentioned. Probably the most important part in making the keyway is preparing a tool which is shaped so that it can actually create the notch in the cam as well as the notch in the key, and the groove in the shaft are all made with the same tool, so therefore they're all exactly the same width, which is 2.5 millimeters. And so this is a tool that I made up for the job, and it worked quite well. Of course, this lathe tool is made by grinding high-speed steel. To have their keyways at different angles, 1 to 5, and 360 divided by 5 is 72 degrees, so these keyways have to be 72 degrees apart. And that's why I've got it mounted here in a 4-jaw chuck, and the plan is to cut 5 separate keyways in there, and I have to divide the angle into 5. And to do that, I'm going to use my indexing wheel system that I made. And normally I use a sawtooth which has 24 teeth, but 24 is not divisible by 5, so that had to go. And instead, I'm using one of the change gears. This is a 60-tooth gear, so it'll be 12 clicks for each keyway. So I just tested it out. It seems to work all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pull it back to lock it in. Put it in back here to hold it steady while you're doing the keyway, and then get my keyway tool, which is here, which I ground specially for making the keyways, and make another keyway slot. Five keyway slots, and there's one cam which I'll use as a pattern for all the rest. So that's the plan. By the way, I discovered another advantage of the design I used for this indexing system, and that is that that shaft is connected with the Morse taper in the front of the spindle. So I had the chuck off anyway and put the shaft through with its Morse taper, but I left it a bit loose because it has to be lined up such that one of those 12 clicks lands where the keyway is currently. So I put the keyway tool in the slot of the keyway. You might be able to make out somewhere in there. Anyway, it was sitting in the keyway slot, and then I was able to turn the Morse taper loose until I had it in the position I wanted on the middle of one of these clicks, and then I put a shaft through and tapped the Morse taper to lock it in. So that's an advantage, is that you can set it that way to any angle initially. The indexing system was required for that master cam that had the 5 keyways in it, but the remaining cams were all starting off as discs, which had the keyways placed in them before they were turned into cams. Now we can actually show you the process we used to actually make the slots. I've tightened up this apron carriage quite tight for better tolerances, but that's making it hard work. That's a good cut. You can see the lathe moving a little bit. It's just mounted on a piece of hardwood timber sitting on top of the bench, and was subsequently bolted to the bench properly, so it doesn't move like that anymore. Lubrication is to give the operator a rest. Doesn't seem to make a difference though. Now, I set the dial to 0 before I started, so I could tell how deep I'd gone. I've gone one full turn, which is 2.5 millimeters, and that was the planned depth. So now I'm just going to go backwards and forward until I stop seeing swarf coming off, and then we'll stop and measure it. And it started off as 9.5 millimeters in diameter, and the depth is 2.5, the width is 2.5. If the depth is 2.5, we should see the measurement of 7. 9.5 minus 2.5. Still seeing a little bit of swarf there. When I think about it, if the keyway is 2.5 wide and 2.5 high, we only need half that depth, which would take us to 1.25 below 9.5. which would give you 8.25, and we're 8.42 now, so that's why it's starting to look about right by eyeball. So I've got to take 25th thou off. Not 25th thou, actually 0.25 millimeters. I completed this project about a year ago and only just now got around to completing the video. This whole process took a whole hour of hard labour. And this was only 5 inches of the shaft. The total length is 10 inches, so it has to be done again for the other 5. I initially started doing it for 10 inches, but I found that a bar sprung out of the way too much. If I had a travelling steady, that would have solved the problem, but I didn't have one. The human shaper is at it again. Getting myself in shape here. The problem with using the calipers is you need something to check it against. So you've still got to You can get the reading quite nicely with these calipers. Feels good. But then you have to measure the calipers. 8.10. Anyway, oh, I wanted 8.25, didn't I? So actually that's probably quite good how it is.